whenever somebody is talking about the intake, vibration, you better find out what vibration they're talking about, because you may feel something they don't feel, and you may work 2 hours on something that they weren't even complaining about. So if there's any, sometimes you think, well, if they're talking about a noise or a vibration, I'll just find it. But that's a bunch of hogwash if you've worked and worked and worked on it and you fix this, and they said, that's not what I was talking about. I was talking about this, and you got to do this to make it happen. Well, wait a minute, what about this stuff I fixed? Well, I don't care about that. I'm not paying you to fix that. See where I'm going with that? That's how that kind of thing works when you're talking about noises. You better make doggone sure that both of you on the same sheet. It's real important to do that, and I've run into that stuff too much at the dealership. One way or another, you got to get as many details as possible from the customer to start with. That's really, in other words, if some service writers don't do that, what they'll do is they'll just, say, tell me about what it's doing. They say, well, it chuggles at road speed or whatever. Let's give you some, or it does this. Sometimes my car makes a noise. I had this girl one time that was driving this pickup vehicle from us going to get parts when I was working down at that offshore services company in the maintenance department. I'd get cylinder heads and stuck up there and all that. Well, anyway, she'd come back up here and she'd say, my car, when I put it in gear, it goes da-da-da-da. What am I going to do with that piece of information? You know what I mean? And I said, put on your seatbelt and drive back slowly, but anyway. But one way or another, everybody's going to be on the same sheet. So with a detailed description of the problem, what you're going to do is you're going to go to the next preliminary step. That's your road test. With the road test, you ought to have 3 main objectives in mind. The first objective is to use the information from the repair order to reproduce a condition. If I'm going 46 miles an hour and I'm driving over a slightly bumpy road and I'm hearing a little rattle on the right front or whatever, or I'm feeling this vibration, and this is where you're going to try to do a similar conditions window. You're trying to go in there, this particular speed, if I got to be going up a hill, make sure that you get out. That's one of the information you get from is important. The second is try to isolate it to a specific location. It's coming from there. It's coming from back here. It's coming from over here. You got me? You got to try to figure out which direction it's coming from. Third, you got to isolate this condition to a specific circumstances and obvious components. Now, what's the last time you worked on something in here that had a noise?
That Mitsubishi.
What was the noise?
It was a jiggling noise in the front end.
Yeah.
It was suspension related.
Yeah, suspension related.
I had a hard time narrowing that one down.
Well, the noises are no fun, I'm telling you. And
I like that one that we wrote that you had to have Quincy in the back, me, and
I loaded all of you big boys in the back, and it wouldn't make a single noise. And I give it back to her, and she'd bring it back, and she said, "It's doing it again." Well, we couldn't get it to do it. She couldn't get it to do it. And then her husband got his phone when it was doing it, and he held his iPhone under there, and I've got the recording in there on my desktop. And he held it there, and whenever you would move it, it would go. It was just awful, but it wouldn't do it for us. And so I just kept tightening those big bolts that went through them rubber bushings on those rear control arms, and eventually we pretty well quietened it out. But what got me was she said she'd drive to Montgomery, you wouldn't hear it. And she would, about halfway back, it would start just squeaking up to beat the band. And I'd hate them kind, because you can't pull a trouble code that's going to tell you about a noise that happens halfway back from Montgomery, you know what I'm saying? They're not going to work. All right, so,
hey,
yeah.
Does a helical cut here have 2 teeth or 1 teeth in contact?
Usually it's got more than one. It's got a couple,
Okay.
The third objective is particularly important since it's going to provide direction for troubleshooting steps that'll follow. In other words, you remember what was the third one? Isolated to specific circumstances and obvious components. Does it occur during braking or steering? Is it engine speed or vehicle speed related? Does it occur when certain vehicle features such as air conditioning are operated? If I'm operating a particular component, do I feel it with the air conditioner on? Do I not feel it with air conditioner on? Am I driving at such and such a speed? Now let me ask, sometimes I'll go, if I'm feeling something that's really strange, that I'm wondering if it's got to do with the engine, or I kick it up in neutral, I'll switch the engine off and just coast. Now if you're slowing down and you're hearing it go, look at that, it's got something to do with wheel speed, right? However, what if you're slowing down and it's actually faster than wheel speed? It's good. I mean, what does that mean? If it's faster, if like every time the wheel goes around, it goes pop, 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 pop. If that's, and the frequency is like 3 times that. You got to find, now what is what's traveling wheel speed, on a rear wheel drive vehicle particularly, what's traveling wheel speed, changing with vehicle speed, but spinning 3 times faster than the wheels.
That would be the drive shaft.
The drive shaft. So, I mean, you see where I'm going with that? That's how you're going to determine what's going on there. So there's a lot of testing techniques you got to use, like, you know, neutral coast down. That's what I was talking about before. Put it in neutral, let it coast down, see what you hear, that kind of thing. Now, if you weren't able to duplicate it, consider the possibility there may be circumstances that didn't appear on the repair order. She may not have told you the whole story. The condition might be load induced, right? In other words, if you're loading it, may need to be driven up or down a hill, maybe related to vehicle operating temperature or ambient temperature. And I think that's what's going on with that squeaking rear suspension on that 2009 Expedition I was talking about. A lot of vehicle dimensions and locations change as the ambient temperature heats up. Things move, expand, and contract a little bit. You might need to talk to the customer or have them go with you. That's what I was talking about earlier. Once you use the road test and narrow it down, the next step is to look for obvious causes related to the circumstances. If the vibration occurs at higher speeds, inspect the wheels for missing weights or mud or other material stuck to the wheel. Who told me about something like that just a few minutes ago? He's driving all on the inside of the wheel. There was mud packed in there and it was shaking your teeth out. So you drive it, you scrape all the mud and wash it all out and clean it up real good and it's nice and smooth again. Quincy had some of that on his, didn't he, Quincy? Don't overlook the basics, such as checking tire pressure and looking for tire damage. You got me? How many of you guys ever drove a car across a parking lot and felt it doing the Watusi? What does that mean?
There's a bump in the tire.
Yeah, you got a bubble in the tire, or the belts have separated, and when you're going across here, it's going to be doing that. So I always like for people to drive it, or I put it on the lift, I spin it, and I look for the tire. They do this. They got to have a tire.
I had a good tire in my front tire on my truck.
Yep.
The belts broke on it. Had a big hump about that big. I didn't notice. I mean,
Well,
every now and then when you start turning,
yeah.
you'll hear it bump a little bit. That's every now and then.
There you go.
Like a month like that.
Yeah.
What car was that we had my last semester out here before this one? Last spring, I think.
Mm-hmm.
What car was it you had me driving around that had a bump in a tire in it? You had me driving
I remember
around.
that car, but I don't remember whose car it was. It might have been Judy McClaney's pickup. That little white pickup.
Yeah, that's right.
That little white Dodge Dakota, you got 94 model.
Yeah, you had me drive that thing around and figure out where it was.
Yeah, and we found it. You ought to check it for aftermarket equipment too, like lift kits and stuff. If it's damaged, installed improperly, or not designed to work with the vehicle, it can be a source of vibration and noise. It's not put on there right. More specifically, well, yeah, I told you about that fighter pilot that I was having this buzzing noise that was coming from behind the speedometer. And we worried with that darn thing, and me and the shop foreman drove it together and all that. And he could take a jacket that was laying over here, and he could hold it up in front of him while he was, and it would drown it out. And it turned out it was a doggone bug shield going buzz. And the old guy that was driving the vehicle happened to have his hands, you know, like you roll the window down a little and you got your hand propped up. He was feeling it on the tip of his finger. And so he would move his tip of his, while he was driving, he was hearing this buzzing, and he'd move the tip of his finger around until it was the strongest on the tip of his finger. And like I say, he was an old Vietnam era fighter pilot that flew the F-100s, and so he kind of knew a little about wind and air. So he gets out and he's looking down his finger and he's pointing right at the edge of his bug shield. So he got some little aluminum strips and some Velcro and strengthened the tips of his bug shield where it wouldn't go bzzz, and all of that noise went away. Well, it drove us up the wall trying to find that dadgum thing because the noise was telegraphing. You'd swear it was coming from behind the instrument cluster. You know, it was actually hitting the windshield and getting transmitted down into the body. That's just crazy as all get out. Okay, let's keep going here. Roof racks. The cross bar, you know, roof racks. The cross bars can be the source of wind noise on roof racks. If you run across an answer, put it down, guys. If they're positioned at the front of the vehicle, you got to note the position of the cross bars on the vehicle and position them to the rear to see if it affects the condition. Something else you can do, you can take masking tape and you can cover up body seams with it, or you can actually cover over little chrome pieces around the windshield. Put tape on that. If you're looking for wind noise, like if you got wind noise around a door or something, you can open the door and you can do Dr. Scholl's foot spray, and you can spray that powder around on that on that rubber, and then whenever you close the door kind of gently and open it back up, the place where it didn't wipe that foot powder off is where your noise is coming from. You can also turn the blower motor on high speed. Put it on norm, or vent, turn the blower on high, close the doors, and go along there with your cigarette and hold it up there by the door, and when it blows the smoke away, making positive pressure inside the vehicle, right? Pulling it in from outside, And if it blows the smoke away, you can find it that way. There's all kinds of stuff you can do. All right, so one thing that can save you time during preliminary diagnosis is check TSBs that apply to the vehicle you're diagnosing, and basically go to Identifix or a place like that. The diagnostic service procedures in those procedures in those bulletins may lead you right to the source of the problem. All right, once you've taken the steps, you're gonna, vibration, noise, or whatever, you're gonna go to a component group, and then you're gonna have to determine what it is. Now, we're gonna look at pinpointing vibration, noise, location, and frequency. What's frequency?
Hertz.
How fast it's vibrating. Is it all that? You can typically tell. So one of the things that people come around here, they'll say, I need an alignment because I'm feeling a wheel vibration at road speed. Well, that's balancing tires. That's not an alignment. You got me? Typically. There's a chassis ear. You know what a chassis ear is? Who many of you use a chassis ear? We got two of them here. We got one of these little radio transmitters. We got one that's got little microphones. You put the headphones on, you put the chassis ear on the different corners of the vehicle, and you can basically switch from one to the other and tell where your noise is coming from. Now you got to recognize these things are pretty doggone sensitive. Huh?
Me and Matt did that on a PT Cruiser.
There you go. There is a sheet on this. There's a sheet that I gave you guys on using the chassis ear to locate a noise driving over bumps and all that. And I
got a noise whenever I hit a bump.
Yeah. Well, that wouldn't surprise me on your truck, Jewel. All right.
Everything squeaks.
You put the sensors in various places on the body, chassis, or engine. You switch between them with a little switch on, and you can isolate a noise to a particular area, and in some cases to a component. When using it, you got to keep in mind the sound's amplified, so you're not necessarily looking for high levels of noise, but differences from known good components. I'm listening to the left, I'm listening to the right. If the right's going roar and the left is going roar, then I'm listening to the difference in those two. See, I've actually got some noises recorded on this machine I can play for you, where we found bad bearings in the rear end on an Explorer. Doing that kind of thing is pretty handy to do that. The chassis ear's got 6 clamp-on sensors. It's connected to the little switchboard thing. Then you got an electronic vibration analyzer. That's really cool stuff. I've used one of these things. And what you're going to do, let's say you're driving down the road and you're feeling a vibration and you don't know if it's engine or whatever related. So basically you're going to take your little vibration sensor, it looks almost like a little scan tool, and you're going to lay it up here on something that's vibrating along with the vibration, like your sun visor or something like that. This seems sort of subjective and stupid, but it works. You lay it up there, and it basically is picking up the frequency of the vibration, and it's telling you what the frequency of the vibration is. Well, then you take that vehicle at that speed with the engine running at that RPM, and you're going to know the size of your pulleys, the size of your crank pulley, the size of your alternator pulley, how fast it's spinning, the size of your power steering pump, size of your AC, you know, all that stuff, the size of your water pump. Let me see who this is. Oh, that's him. What's up? Hey. Hey. Yes? Okay.
I told you not to. You didn't tell me to do anything. Said not to do that.
That's a good one.
You stuck a cap down there.
Yeah, send me the one you got, and I'll look at it. All right.
Bottle cap.
Okay, basically that's your expansion valve deal there.
I'll get that with 2 pliers in there.
Wow.
What's there?
Okay. Now then, let's go here. So you got this thing, let's see, it's got a frequency, if the condition's a noise, it has a frequency of at least 20 hertz, and could be as high as 20,000 hertz. What's a hertz? What's 1 hertz? 1 cycle per second, right? Okay, with the electronic vehicle analyzer, you get a definite frequency that you can associate with a rotating component once you do the necessary calculations. If you've never used it, don't be put off by the high-tech sounding name. I mean, I would be put off by the high-tech sounding price. It's like from $2,000 to $5,000. It's real expensive to buy one of these darn things. Right. Okay, it's got inputs for sensors A and B, so you can switch between readers for those sensors. You got a screen there that you can read and all that. There's a keypad, and we're going to go through this pretty quick. There's actually this cerometer. There's a cerometer, which is a little thing you can actually turn, and it runs this little antenna looking deal out, and you can basically look at the frequency whenever it reaches the frequency of the vibration. And this thing is not even related to the electronic vibration analyzer. It's a mechanical vibration analyzer. When you get that thing out to a certain level, if it starts resonating with the vibration, you know what the vibration is. I mean, this is probably something that unless you get heavy duty into, dealership work, or you're having to work on brand new cars, you may not ever go this deep into something like that. You got wheel and tire balance checks. You can do either wheel balance and all that kind of thing. Now what I'm going to do right here, look at tire wheel frequency. Let's see, tire and wheel frequency calculation will be like 5 mile/hour increments times tire and wheel revs. Now how would you be able to tell how many tire and wheel revs, how fast is my tire, how many times is my tire spinning if it's 10 foot around, and if it's 10 feet around that tire? To begin with, how do I calculate that?
Tape measure.
That's one way, but why don't let's do that, but let's put a mark on the floor and a mark on the tire.
Roll that.
And let's roll it so that it goes one full roll, and then when that mark comes down again, we're going to mark it again, we're going to measure the length of that tire. Okay, now, we're going 60 miles an hour. We need to know how fast that tire is turning while we're driving 60 miles an hour, don't we? How fast is it spinning? What's the frequency of the rotation of that tire at 60 miles an hour if it's 10 feet around? How many times is it going to spin? How many times is it going to roll over in a mile if it's 10 feet around?
Okay, so that miles what?
5,280 feet.
Okay, so,
Divide that by 10.
yeah,
522.
528. It's going to spin 528. Okay, so divide that by 60.
I don't have
60
my
miles an hour.
8.8.
Huh?
8.8.
8.8. Okay, so now you know what the frequency of the spinning of that tire is. If your electronic vibration analyzer is telling you that it's 8.8 hertz, then you know you're feeling a tire and a wheel, or something that's spinning at the same speed as the tire and a wheel, which is going to be what? CV axle, brake rotor, drum, this kind of thing. Is this complicated? Are your eyes glazing over?
Yeah.
Okay. All right. But you got to be able to do that. Okay. Let's suppose a vehicle is equipped with P195 70R14 tires. They revolve at 1.17 times per second for every 5 miles per hour of speed. You got me? So if we're going 1.17, how many times 5 going to 60?
12.
12. Okay. So what's 12 times 1.17?
12 times 1.17.
Yeah. Joe's yawning over there. He's about to turn into a skeleton.
I'm not turning into a skeleton.
14.04.
Yeah, see that? See how fast it's going? So to find out the frequency is 60 miles an hour, you multiply that in 5 mile increments by the time the tire and wheel revolve in 1 second, and that's 14.4. So at 60 miles an hour, the tire and wheel frequency would be what?
14.04.
14 hertz.
Not 14.4.
14 hertz, yeah, roughly. So we can calculate the various orders related to this frequency. A second order vibration would be what? In other words, if it had 2 bumps per tire rotation, that's 28. You got me? The fourth is, the third order is 42, fourth 56, fifth is 70. See where I'm going? Got it? All right, the frequencies are calculated here. All right, now then, you got tire and wheel, you got pinion shaft, you got prop shaft, you got transmission output shaft, pinion shaft. I mean, all of this stuff is going. Engine speed, basically. So engine speed in hertz. How many times the engine rotates in 1 second? That's associated with the crank damper, crankshaft, flywheel, torque converter, all that stuff. You know what the guy did when I went to the school on this? He put a bunch of washers on one of the torque converter bolts. And we had with vibration, we had to find that sucker using this machine and doing the calculations and all that. This is not for the faint-hearted. It's not for lazy wimps. Was that? How many of you people think mechanic work is for lazy wimps? Raise your hand. All right, Bobby, I figured, Bobby works about as hard as anybody in here. All right, accessory drive belt frequency. Think about all the different pulleys and the difference. I mean, see all the stuff you got to figure on this? Okay, let's go through our test right here. I just wanted to expose you guys to some of this because I knew you would probably surely die.
I don't know.
All right.
I was wondering when you get to the test.
Yeah.
I'm sitting here,
You should
write down answers whenever they come up. So I'm sitting here listening and trying to write, and there's nothing coming up.
This test right here is a meat grinder. I mean, it really is. But I just wanted to tell you this is what things are doing. During a neutral coast down test, the vibration remains the same. Of the following components, which is the most likely source of the condition?
Tire wheel.
Everybody like that answer? Well, he must have learned something during steering input test. 1, driving through wide turns with a vehicle in gear, a noise gets worse. Which of the following is most likely to be the cause of that?
Worn wheel bearings.
Worn wheel bearings. Like whenever you swerve back and forth, like if I swerve the engine, if I swerve the wheel, if I'm driving 60 miles an hour and I'm on an open road where there's not any danger and there's no cops out there that's going to give me a drunk driving ticket, I'm going to swerve a little bit, and I'm going to hear a difference in the noise. If I swerve to the right and the noise gets louder, and I swerve to the left and it goes away, what's that telling me?
Left bearing.
Why?
Because when you swerve to the right, you're taking the load off the wheel on that other
Off of
side.
the right one, right?
Yep.
And you're loading the left one heavier.
Yep.
Now be careful with this, because you can get fooled. Because sometimes, occasionally, you'll run into a situation where you just swear it's the left front bearing, and it'll be the left rear one.
Can't you do a run-out test on it?
Huh?
A run-out test?
Well, a run-out test's not going to help you. If that bearing's is brindled on the inside, it's not going to show up with anything except noise. And some bearings won't make noise unless they're loaded. If you jack it up off the ground and turn it through, you may not hear anything. You may have to have all the weight of the car sitting on it. And that's annoying too. But you gotta have to put up with this. Stethoscope helps, or the chassis ear. That chassis ear helps too. Which of the following can you do using the keypad on the electronic vibration analyzer? Now we didn't really get into that, but that's D. All of the above. It's not too hard. Which of the following tools would be the best to use to balance a prop shaft?
An EVA with strobe.
How many of you guys have balanced a prop shaft? Prop shaft being a drive shaft.
Special tool.
Yeah. What do y'all
64, 54.
Oh, yeah, but why don't we use any kind of tools?
Yeah, you basically used, well, what you would do, if you got a drive shaft vibration, and the drive shaft vibration is not hard to pick out. They'll come and go at various speeds and all that. And like some, drive shafts are balanced from the factory, but occasionally something will happen and one of the weights will get knocked off of it, and it'll wind up, have a real high frequency vibration.
Curb bump.
Yeah, and so what you do is you put it up on, remember what you guys did? You put it up on a jack stands, and you get up under it, and you get a bucket or something that's putting you about even with the side of the drive shaft, and then you have somebody to spin it up to 46 miles an hour wherever it's doing this vibration, and you be careful and steer clear of moving parts, but you slide a pencil toward the drive shaft real slowly until it touches, just barely starts to touch, and it's only going to touch on the side that's bellied out. It's heavy, you know what I'm saying? All right, then you move that, switch it off, and you're going to see a pencil mark on one side of that shaft. Then you put 2 hose clamps on that shaft so that the screws are on the opposite side of the pencil marks.
There's some dude out there.
You got me? And I'm in class right now. So anyway, on the opposite side. And then you drive it again, see how it feels. If you don't like it, you move them. You ready to move the screws to where the actual screws on those clamps are what's going to be your weights. And they're not going anywhere. They're going to stay there, but it works really good for that. And you start out with them together, and then you move them like a few degrees until you get it perfect. You can balance the drive shaft where it's absolutely perfect. They do this at tire stores all the time. It ain't complicated. All right, because people will say, I got wheel vibration. They find out about the drive shaft, and they can fix that. Let's see. Truck with a tire size of LT 215, 85 or 16 is traveling 60 miles an hour. What's the first order frequency of the tire and wheel with that speed? What do you think?
155.
That's not on there.
11.4.
16.2.
11.4. Making it up as you go, Bubby. 11.4. Now, how are you supposed to know that by road? You can probably have a chart, don't you? A truck with LT 255 60 or 16 tires is driving at 60 miles an hour. If the axle ratio is 355 to 1, which of the following is closest to the prop shaft frequency?
326.
Anybody know?
2.6.
Huh? 46. 46. Vehicle 6-cylinder engine is running at 2520, 2,520 RPM. What's the engine firing frequency in hertz? It's a 6-cylinder. What you gonna do? You gonna do the math on that?
It's 420.
126. You get it? You can do that in your head? What's up with you all? It helps that I've got the answer key. A V8 engine has a crank pulley diameter of 9 inches and a generator pulley diameter of 3 inches. What's the generator frequency at engine speed of 2,400 RPM?
227.
See, basically what we're doing, that's actually 120. If the engine, the alternator is really small. The alternator is really small, and if you're spinning, it can spin 14,000 RPM. It's just screaming. The alternator just going crazy, because it's got a little pulley. The bigger pulleys are on the ones that are harder to pull. Power steering pump, air conditioning, water pump. Those are harder. It's harder to spin those, so you put bigger pulleys on them. They don't need to spin as fast, but they need to spin with a lot of power. And so you got to keep that in mind too, because the frequency of those things. Okay, let's see. Where are we at? Which of the following components is the most likely cause of a vibration that has a 5th order tire and wheel frequency? What do you think?
See.
CV joint. You got 5 balls in there, 5 or 6, right? Which is the most likely cause of a vibration that has a frequency twice that of the engine in the 4-cylinder engine? Exhaust system. Now listen to this. I'm going to tell you something here. Well, the reason what we're doing here with this is anytime you're trying to troubleshoot something that's like what we're talking about here, you're going to need to know what the data is that you need to sort out in order to figure out what's wrong. You got it? Did everybody in here make 100?
Yes.
I wish.
Yeah.
I wish you all made $100 right there.
All right. Put those tests out there in your racks and all that. And we'll be, lunchtime is in a very few minutes.